Photographers often use software like Adobe Photoshop to enhance their photographs. Sometimes they apply the same manipulation again and again to every image in a collection. Photoshop provides basic macro authoring so that photographers can record and replay a sequence of operations. Here the user applies a sepia tone macro to several images. But these basic macros cannot adapt to the content of the target image. For example, here the user records a skin tone correction macro. When applied to a new image, this macro fails to adapt because it does not know where the face is located. Even after manually correcting the selection, the macro fails because the color adjustment parameters in the example demonstration do not work well for this new image. We present a framework for automatically generating content-adaptive macros from multiple demonstrations of the same manipulation. Our approach combines image recognition with machine learning to build these macros.
Here's the typical workflow. To create a macro for adding lip gloss, the user first demonstrates the manipulation on a portrait. The labeling correction panel shows a list of facial features our image recognizer identified. As the user selects a region in Photoshop, our system recognizes it as the upper and lower lips, and automatically checks these labels in the list. The panel provides feedback showing that the system properly interprets the selection. Next, he adjusts the hue saturation and the color histogram of the lips. The last step is to paint a highlight on the lips. After the user performs the first demonstration, our system creates a macro application panel that shows how the image appears after each step of the manipulation. When the user encounters a new portrait that he wants to apply lip gloss to, he selects the lip gloss macro from the list of all recorded macros, as shown here. The panel now shows the result of automatically applying the macro to the new target image. After only one demonstration, the results will likely require some corrections. For this image, we immediately see that the first step of the adapted macro is incorrect. The lips are in the wrong position. The user clicks on step 1 and corrects the selection. Then, he switches to the labeling correction panel and checks the upper and lower lips to associate these labels with the corrected selection region. He switches back to the macro application panel to apply the changes. The adaptation looks pretty good, but perhaps the effect is a bit too strong, so the user clicks on step 4 and adjusts the color curve parameters to decrease the redness of the lips. Applying the changes propagates them through the rest of the macro. Our framework treats each corrected macro result as an additional training demonstration to improve the quality and robustness of the macro. After 4 demonstrations, the system runs a leave one out cross-validation to estimate the macro's robustness. For every new target image, the panel displays the average error for each step to indicate the system's confidence. High values are shown in red so that the user can quickly check whether these steps need to be corrected. As the user adds more training demonstrations, the macro becomes more robust, and the error values decrease. Our experiments indicate that our macros produce consistently good automatic results after about 20 demonstrations. Our macros can also be applied automatically and in batch mode, rather than using the panel.
We tested our system on 20 example manipulations. Here are some results of the learned macros for these manipulations. For a complete set, please see the website we submitted as supplemental material. Here is an example of adding a mustache to the portrait of a man. We now transfer the manipulation to new target images. The transfer is successful for a person with dark hair, but when the macro is applied to a person with light hair, it looks very unnatural, even if the location of the mustache is correct. Our system is not able to learn the dependency between hair color and mustache color. An interactive machine learning approach would help in these situations. To evaluate our system, we compared our macro results to manually manipulated ground truth images in a simple baseline technique. We asked viewers to rate the differences between the manipulated images for 7 manipulations. Our results consistently outperformed the baseline and were often indistinguishable from ground truth. These studies show that our framework can successfully adapt complex photo manipulation macros to new images in a content-dependent manner.